Well, let's start the video. And today for this diagram we have to determine the shear stress diagram and the moment diagram. So let's get started. So first of all, what we're gonna do is we're gonna draw this line. This is another force line. So whenever the point force is applied, we're gonna draw the lines. Okay. Okay, so this is our force. These are two forces, and this is another point, and this part of the beam is jointed on the wall. So let me change the color. Okay, so first of all we have to determine the normal forces, or we have to determine the opposing forces or reactant forces acting on this plane. So okay, so the reaction force will be one reaction force will be over here, that will be our a y. Okay, so there are actually only one reaction force, and the two other forces will be uh, remaining from this two. Okay. Okay, so in okay, let's take action. Okay, so this is our line, and now we have to determine what is the value of ay, then what is the uh, then we have to go forward in the determining the shear stress diagram. Okay, so while doing that, if we use the equation summation of f of horizontal forces, or no, I mean vertical forces, as in this point horizontal forces will be 0. Okay, the horizontal forces will be 0. So let me show you this. F of the horizontal forces, it will be equals to 0, and if we determine, then f of, if I just assume that this is f of x, then f of x equals to 0. So it is not actually helping me in anywhere, so we're not gonna use this that much. Okay, so let's move forward. Okay, so moving forward to this f of the vertical forces, so it will be 0, and thus it will be ay equals to, well, one sec, it is not ay equals to, it will be ay as it is going upward. These forces, one force going upward, this will be equal to the forces going downward, so it will be 2 plus 1.5, thus it will be 3.5 kilo newton. Okay, so we have determined the value of ay. So we have determined the value ay. Okay, so after determining the value of ay, what we're gonna do is the ay is 3.5 in which direction? In the upward direction. Okay, so the force is 3.5 newton in the upward direction. So we can create this line that it will go from here to here, that will be 3.5 kilo, and between these 2 points there are no other forces. So for this will be a straight line till here. Okay, and after that it has came down 2 kilonewton, so in that downward. So if we calculate 2 kilonewton, so it will be like this. in this point. It means 3.5 minus 2. So 3.5 minus 2, that will be our 1.5. So we are getting 1.5 kilo Newton. Okay, done. And after that, our 1.5 kilonewton, it will go till here, it will be a straight line. Okay, and because between these 2 points there are no other forces, point forces, or any other kind of distributed or undistributed loads, there are none, so it will be a straight line, and in this point it will go down to 0. Always remember that the shear stress shear stress diagram or the moment diagram, everything will start from 0 and will end from 0. Okay, so the starting from 0 and it will always get into 0. Okay, so let me change the color. So as this is in the positive direction, so this will be our positive and this will be our positive shear. Okay, so let's go to the next diagram. So okay, so this is our SFD, and now we are going to draw the BMD diagram. So for the BMD diagram, let's do our calculation. Okay, so on this point AY is moving upward. Okay, so if we calculate, or if we think that here we will get a movement, okay, this is, let's say it M of A in this direction is positive. Okay, so if we calculate this one, so let's calculate the moment. Also we can calculate the moment from this. Okay, so if you calculate the distance from this point to this point, okay, so it will be 1.5 minus 0.5, it means 1, right? Okay, so 1 multiplied by 3.5, that will be 3.5. So 3.5 will be the 3.5 will be the 3.5 will be the the moment, but we'll not gonna do like that. We're gonna change the way we are gonna determining it. Okay, so to determining it, what we're gonna do is, okay, so determining that, we're gonna do, let me change the color, do something lighter. Okay, no, this it's not visible, so let's take it black. Okay, so now let's calculate the moment. So while calculating the moment, let's know another equation, that moment is equal to 0, summation of moment equals to 0. So summation of moment equals to 0, so what we're gonna do is, let's calculate a moment over here. Okay, so by calculating the moment, what we're gonna do at point A. Okay, so at point A, let's assume that the moment will be m of A. Okay, so if you assume that m of A, then m of A equals to the summation of these sides forces. So how can we determine that? So to determining that, sorry for the interruption. Okay, so to determine, okay, so to determine that, what we're gonna have to keep in mind that the forces, okay, so let me assume these two. Okay, so the forces going to this direction, let's assume this is the force. Okay, so this is the force, and the forces that are going up this word upward, okay, upward, those will be positive. Okay, and the forces from the left side going this way, this is positive. Let me tell it again. Let's assume this is the force line, or this is the point force, and the forces that are going from the right side this way, those will be positive, and going this way, they will be also positive. and this will be negative. Okay, again this is the force or force line, and the other consecutive forces, those are going from the left side this way, that will be negative, and right side this will be also negative. Okay, so after saying that, let's apply it in our m of a point. So in our m of a point, what will be this? It will be, let's this way. So this is the right side, so right side this is going, this both of the forces are going downward, right? So 2 kilonewton will be negative, negative 2 multiplied by the distance is 1, negative 1.5 into the distance is 1.5. So the value of ma will be 2 minus 1.5 into 1.5, that will be 0.25, 0.25. Okay, so this is in the point of ma. So ma force will be starting from 0.25. Okay, so you think that it will start from 0.25. Then let me see one thing, one major discussion over here. So yes, it will. Okay, so 0.25, and it will be on the okay, so I think I have done a calculation mistake, sorry. It will be actually 4.25, sorry, it's my calculation mistake. It will be 4.25 in the negative direction. It will be minus 4.25. Okay, so as we are determining that this will be minus 4.25, so from here we will go. Okay, so let me determine all the forces together. So this is our ma. Then actual this way we can determine m of c. It will be m of c will be the forces on the right side or left side. We can take any side of the forces. We will not take both sides. We will just take one side of forces. So let's assume from here, from for m of c, the forces on the left side, that is going this way, right, downward, so this way, so it will be negative. So it will be negative 1.5 multiplied by the distance is 0.5. Okay, so that will be 1.5 into 0.5, that will be 0.75, and the negative on the front. Okay, that means that, okay, so here we have to assume one, look one thing, look, so the force is going actually downward, right? So as the force is going downward, so we'll have to go 0.75 from this point. Okay, from this point to this. Okay, so we're gonna do it later. Okay, so m of c, and in the point m of b, it will be, if we do the summation, m of b will be 0. Okay, so in this, in the end, it all turns into 0. So let's do it. If in m of a it's minus of the minus 4.25, so we're gonna come over here 4.25. Okay, from 0 we have came to 4.25, then we have to go from here to this is 0.75, so 0.75 from here to here. So as this is a straight line, so it will be a linearly bended line. Okay, okay, so after that, let's see, here it will be 0 and it will meet to 0, and as it is a straight line, then it will again go bend to 0. Okay, so this is the thing, and this is how we have determined. And here this will be negative and this will also be negative. So this is how we determined the SFD and BMD diagram for this calculation. Thank you.